So we move directly into our startup pitches. So first, we have a finalist from the previous My EU Space competition, as mentioned by Yuspa yesterday. The startup is called PITS with a Z, and will be presented by its CEO, Isabella Anna Hubner. Hubner has 6 years of experience in corporate finance and strategy and is currently doing her master's in technology entrepreneurship at the Technical University of Denmark. So, Isabella, the floor is yours.
Here. So, welcome all again. My name is Isabella, CEO, and I will present you PEATS today, an early-stage startup from the Technical University of Denmark with a strong vision. We want to empower peatland restoration actions by monetizing carbon reductions. But let me start with a question. Aren't we all aware that we need to do more to mitigate climate change? Next slide, please. 90% of European companies would answer this question with yes. 60% of them have a sustainability strategy, but lacking when it comes to implementation, with serious consequences for their future businesses due to changed environmental awareness of customers, investors, and the government. Next slide, please. PEATS addressed this critical gap by enabling companies to embrace sustainable business. We offer our customers a comprehensive service to turn their environmental aims into action by partnering them up with verified peatland restoration projects. Next slide, please. But why should we focus on peatlands? Because they are our most efficient natural and local carbon storage. It stores twice as much carbon as all forests on Earth together. Especially in the Arctic areas, peatlands play a crucial role, covering 70% of the region. But peatlands worldwide are under threat and emit 2 billion tons of CO2 per year. These emissions can be stopped by restoring degraded areas. Next slide, please. But PEAT's aim is not only connecting the industry with restoration projects. We go one step further. We use Sentinel-1 and 2 data for credible reporting of the project's progress, ensuring a maximum of transparency and quality. Next slide, please. And this is just the beginning. Our data-driven approach will offer a transparent and credible evaluation of the achieved carbon reductions, with the aim to turn them into certified carbon credits. And this step will turn peatland restoration actions into a sustainable business opportunity for the future. Next slide, please. Summarized, our customers benefit from choosing the projects that fits best for them, with the knowledge to invest into a long-term carbon storage solution and the necessary confidence to share their environmental engagement with others. Next slide, please. Our vision is to empower peatland restoration actions to mitigate climate change. Therefore, PEATS aims to establish an additional funding source for restoration projects and to increase the awareness about the enormous impact of peatlands for our environment. In addition to that, we aim to provide our insights from peatland long-term monitoring as an additional data source for further restoration actions and the research. Next slide, please. On our way to realizing our vision, we rely on strong partnerships. Our first step in this direction is the pilot project with the Ove Jensen Foundation, Denmark's biggest peatland owner. But as you can see, they are not the only ones that we could convince by our idea. The European Space Agency invested 10,000 euros in us as the winner of the My EU Space competition, the category Green Planet. This investment enabled us to fund several licenses and hardware improvements. Thanks to this investment, we were able to speed up our data processing time significantly. Next slide, please. Besides strong partnerships, we need a powerful team. And at the moment, it's Adam and me, supported by our experienced board. But we are already combining Earth observation and business skills. But we are in the process to expanding our team in the areas of climate change and software development to master the task ahead, making PEATS a vision from a vision to a reality. Next slide, please. Thank you again for the opportunity to present PEATS. That's it from my side, and in case of open questions or network opportunities, please don't hesitate to contact us via LinkedIn or our website. Thank you and enjoy the rest of the workshop.
Thank you, Isabella. So our next pitch will be from the winners of the second Cassini Hackathon, which was organized last year. The hackathon was focused on the Arctic and Arctic applications. The winning team was the app Arctic Soil Erosion, which later developed into the Iceland-based startup Fletan. We have here with us today one of the co-founders, Daniel Fernandez, who will give us a quick introduction to the startup.
Hi, so I'm actually Aramanga. I'm going to be presenting on behalf of Daniel because Daniel had an unfortunate clash with this particular workshop, but I am also a co-founder of Fletans. I'll be presenting, and if you don't mind, I'll also be sharing my slides as well because we've updated the slides since we last sent them to you.
Okay, seems to be working, so.
Okay, good. Thank you. All right. Sorry about that. Okay. Hello, everyone. My name is Aramanga, as I already mentioned, and today I'll be speaking to you on behalf of Fletan, which is a very early stage startup company that started a few months ago, less than a year ago. So the team at Fletan have been working on building a pipeline to predict and map the risk of soil erosion in Iceland using a combination of remote sensing and machine learning techniques. And today I'll be taking you through some of the preliminary results of this work. But before I get into that, I'll just introduce you to the Fletan team and our journey so far. So we are an international team originally from 5 different countries around the world, and we've been brought together on this project after the team won the Cassini Hackathon at the end of last year. And as part of that success, we were fortunate enough to receive mentorship and sponsorship from the European Commission, which we're very thankful for because without it, we wouldn't be where we are at today. And since then, we have had the opportunity to participate in the My EU Space Competition. We have received funding from RANIS, which is the main scientific branch of the Icelandic government. And we've also collaborated with Landgræðslan, which is the soil conservation agency of Iceland. And they provided us with essential data for our work. So why are we interested in predicting soil erosion? The main reason is that soil erosion is a pretty major environmental threat around the world at the moment. And in particular, it leads to consequences like desertification, loss of biodiversity, flooding, droughts. It can also damage infrastructure. And in the Arctic region in particular, it is already threatening coastal communities. Soil is also known to be a carbon sink. So if it erodes, then it will release greenhouse gases, and that will also contribute to global warming as well. So there is quite a strong motivation to predict soil erosion because if we can predict it accurately and in a timely fashion, we can do something to mitigate it before the erosion becomes severe and before it starts causing any problems for us. And additionally, if we can identify which regions are at risk of eroding, we can provide a quantitative assessment on the impact of climate change and better informed, and that may lead to better informed decisions on conservation policies. So our focus presently is on soil erosion in Iceland only, but we do hope to expand to the Arctic region in general. Iceland is an interesting case study because it's currently experiencing desertification to the point where the government is actively aiming to bring soil erosion under control. In Iceland's case, the desertification is mainly caused by the combination of years of grazing along with sensitive soils and vegetation. But soil erosion is also an issue in the Arctic region in general because the Arctic is currently experiencing a lot of rapid environmental changes due to warming temperatures, and that includes increased soil erosion. So it's also relevant to the general Arctic region. In particular as well, there is a significant carbon sink in permafrost in the Arctic. So if the soil erodes, then that will increase the chance of thawing, which is also a major environmental concern. But beyond environmental reasons, we also chose Iceland because it keeps a long record of environmental studies on erosion, which means that there is a lot of good data that is available for us to use for our purposes. So what we have done so far is we have trained a machine learning model that predicts the risk of soil erosion based on remote sensing data. The input data that we use consists primarily of satellite imagery from Sentinel-2. Specifically, we've used data from the red, green, blue, and near infrared bands. And we've also included some height and slope data derived from digital elevation models. And we've also got ground truth soil erosion measurements taken by Land Gradesland as well. The data that we used from Sentinel-2 was obtained between July 2019 and September 2021. And it's largely only in the summer months because that's where we expect less snow cover and cloud cover. The algorithm that we used to train the predictive model was a random forest algorithm, and the output of that training was a model that we can use to predict soil erosion risk in any area of Iceland. So in terms of results, the model currently achieves an accuracy of about 93%, which is pretty good. And on the bottom right of this slide, you can see a visual representation or map of the erosion risk that is predicted by the model that we trained. There is a true color image on the bottom left, which shows the underlying land that we are predicting on, and the top image shows which part of Iceland that the region is in. So the dark red color indicates highest erosion risk, while the dark green indicates the lowest erosion risk. And as you can see, the predictions match what we would expect from the underlying geography. In particular, the green vegetation patches are classified as low risk, which is what we would expect. So overall, these results are quite promising, and we believe that we have the basis of a reliable and cost-effective way to identify Arctic soils at risk of erosion. And in the near future, we'd like to enhance our current results, potentially through experimentation with other approaches such as deep learning models. And when we've finalized our technology, we'd also like to apply it to other Arctic regions such as Greenland and Canada, and eventually worldwide as well. If you're interested in learning more, there will be a paper coming out in the MDPI journal by the end of this year that describes this work in more detail, but you're also free to find us on LinkedIn or chat to us as well if you're interested in learning more. But that's it from me for now. Thank you for listening.
Thanks so much. Yes, very interesting indeed. So we have a question for Pete in the Slido chat. And I do think we need a little stretch now. I know I do. So I propose that we have a 5-minute break before the next moving on to our last session, and we'll meet here again at 4:05. Thank you.